In this video, we're going to work through number 4 in our additional proof packet. The first thing I notice is that all the information I see has to do with lengths of line segments. So there's no angles in here. So that kind of tells me any property or postulate that has to do with angles, we are probably not going to use in this proof. So we're given that PR is equal in length to QS. And we're given that the length of PQ is equal to the length of RS. Our goal at the end is to try to prove that PQ is equal to RS. I think I saw a mistake. I don't think this is supposed to be here. I think this was not supposed to be given. This is what we're trying to prove. So we're just going to take out this extra step. Okay. That's a typo. Okay. So we know we're given that PR is equal to QS. And we're trying to work our way to prove that PQ is equal to RS. All right, so in statement 1, we can see this is what we're given. So that reason is given. I'm going to head to statement 3. I'm going to start keeping track of some colors here. I'm going to let PQ be orange. And it tells me the length of PQ plus the length of QR equals the length of PR. So here's PR right here. What I'm noticing is they're telling me this piece plus this piece, or this part plus this part, equals the whole. So we've got an addition property right here. 2 parts equal the whole. Well, what are we adding together? We're adding 2 little line segments to equal the whole line segment. That's the segment addition property or postulate. Remember, you can also abbreviate that SAP if you want. Okay. So now we're looking at statement 4. This one says QR plus RS. So I'm going to get a different color this time. QR was in yellow. I'm going to make RS in blue. Is equal to QS. So if I'm looking where QS is in the picture, that's this piece. So yellow plus blue equals the whole QS. That's another part plus part equals the whole. So again, we're adding 2 little line segments together to get the length of the whole line segment QS. That is another segment addition postulate, SAP. So now we're looking at my 5th statement. And I can tell from here this is not going to be any kind of segment addition postulate because there's no part plus part equals a whole. And so this is kind of telling me that this statement is probably coming from the ones up above. So we kind of have to figure out how are they getting statement 5 from the ones we already have. So one thing I'm noticing is in this equation that I see, I notice I have PQ plus QR here on the left side of my equal sign. And sometimes it's helpful, see if you can find that somewhere up above. So this expression PQ plus QR, do I see that anywhere up above? Well, I see it right here, right? I'm going to look at this side of the equation. QR plus RS. Do I see this piece anywhere up above? Well, there it is. So what's happening here? Somehow they're using these statements to say that these 2 things are equal to each other. Let's see if we can try to figure out what they're doing. In statement 3, they tell me PQ plus QR is equal to PR. And then the fourth statement, they're telling me QR plus RS is equal to QS. Well, if you notice, these two lengths, this was given to us that they were equal. PR equals QS. So if these guys both equal PR and QS, they have to equal each other. Right? So you could think of this as the transitive property. Or some people think of it like this. I know that PQ plus QR equals PR. So I could imagine taking this piece of my equation and substituting it in for PR. And similarly, I could take QR plus RS and I could substitute it in for QS into this equation. So another way to think about it is we're using substitution, and we're substituting these expressions in for the equation in statement 1. So substitution would also be an okay property to use here. All right, so now we're looking from step 5 to step 6. What's happening here? And what I notice is that I have part of this equation from statement 5 already. Notice I've got the PQ plus QR on this side, and I've got the QR plus RS. What I do see that's different is this length QR is being subtracted on both sides of the equal sign. They're trying to get rid of that length so that they can eventually conclude that PQ equals RS. And so we see this subtraction on both sides. Anytime you subtract something from both sides of the equal sign, you're using the subtraction property. And so then from statement 6 to 7, they're actually combining like terms and they're canceling. So if you can imagine in statement 6, when you subtract QR, these cancel and you're left with PQ on the left side. And when you subtract QR on the right, these QRs cancel and you're left with RS on the right. And so remember, when we combine like terms and we cancel to get a more simpler equation, we're simplifying, we're using substitution. And we have just proven that the length of PQ is equal to the length of RS.